Let's review page 1 of your MT8 LT3 assignment. First thing, don't forget your name. Can't do anything, can't give you credit if you don't have your name on it. Second part is questions 1 through 14. Do those in ALEKS before you work on anything else. Okay, on question 15, Hensley wants to find the area of this entire rectangle, including the mat. So the 80 plus the matting, which is x. So I'm going to have to write an algebraic expression for the length and the width. Notice I've got x here and x here. So I got 2x, and then going across, that's 8. So in other words, we're going to say this is 2x plus 8 for the length. And we'll do the same thing for the width. That looks like 2x plus 10. So in other words, we take 2x plus 8 times 2x plus 10. This is similar to the problems you did in ALEKS, except you had to look at the rectangle here. So we double distribute. 2x times 2x is 4x squared. 2x times 10 is 20x plus 16x, because 8 times 2 is 16, plus 80. So we're going to get 4x squared plus 36x plus 80. And that's our first choice, isn't it? So we're going to say 4x squared plus 36x plus 80 would be choice A. Let's take a look at our second problem here. Now what happens is I got this square that has side lengths of x and another square with a side length of x plus 3. So I've got x and x plus 3. And I draw the second one very big, much bigger, but it should be bigger. So I want to find the area. Well, the first one, x times x, that's x squared. Don't have to do too much for the first one. So that's x squared. The second one is going to be x plus 3 times x plus 3. And so we get x squared plus 3x plus 3x plus 9 when we distribute. Our x squared plus 6x plus 9. That would be the area of the second one. Now in question 17, said if the area of the largest square is 15 more than the area of the smallest square, I want to find the value of x. So we're going to make an equation out of this. And so if I add 15 to the smaller square, I'm going to get the bigger square. So if I subtract x squared from both sides, notice they cancel. Because x squared minus x squared is 0. So my new problem, bring down the 15, equals 6x plus 9. So now let's subtract 9 from both sides. And we get 6 equals 6x, or x equals 1. Is the value of x. Now to find the area of each square, well, if we're doing the small square, that's x. Whoops, I always forget to do that. Pull that up too. So the area of the small square is x squared. So I'm just going to say, oh, x squared would be 1 squared then, wouldn't it? Which is 1. So the area of the small square is 1. Let me see. Did I have any units with this? No, I did. So it's just 1. Now I will do the large square. Well, that's 15 more, isn't it? So my large square is 15 more than that, which is 16. Notice you could have replaced x with 1, and I got 1 squared plus 6 plus 9, and I get 16 no matter how you do it. And I think that's it for this page, but let me do a quick check. Yes, we'll do the next one in the next video.